All right, so let's start this course in statistics. First, we should talk about what is statistics. Sadly, I have never actually read or heard a very satisfying definition for statistics. In my own, probably unsatisfying to you definition, it's a branch of math that has been developed over time and shown to have validity in humans' ability to grapple with how uncomfortable we are with the unknown. So there you have it. My own, probably unsatisfying definition of statistics. Let's look at what we can say definitively is true. First, it is a branch of math. It isn't necessarily as concrete as some of the math you've done up until this point, or really all of the math you've done up until this point. It's not so concrete, but it's definitely an application of mathematics. It also has its own language, so it can seem very mysterious. I don't know how to spell that. That's as good a guess as I have. It can seem very mysterious, but the mystery comes out of the fact that it has its own lingo. It uses words that may sound familiar but be used in different contexts, or words that sound completely unfamiliar, and you have to get your mind around what the various meanings of all those words are. So let's break it down a little bit. I'm just going to start at the beginning, and we'll take baby steps through the whole semester until you grow, hopefully, more and more comfortable with the ideas that we'll be using. So let's start with a little discussion about the two different branches of statistics. So you can break stats into two branches. The first one being descriptive statistics. And descriptive statistics is really exactly what it sounds like. It's the branch that concerns itself with describing the results of some statistical evaluation. You will see lots of pictures, various types of graphs and charts, to help the reader or the listener understand the data better. They produce for us something that we can see easily, but sometimes you'll see paragraphs of description. Graphs. So you recognize these because they usually start with lots of words and then start having, you'll run into a few percents, or you'll run into some ratios, or you'll run into some lingo. And I think the most familiar you are with this sort of statistics is really watching the weather forecast on the evening news. You've got a person that stands in front of a picture so that you have a graphical or a pictorial way to look at the situation they're trying to describe, which is created based on statistical analysis, but to describe it to you, they give you a picture to show temperatures over the state or wind speeds over the state if you have a big storm coming in, that sort of thing. Often they have graphs and charts that compare weather by one parameter over time. So 6 or 7 days in a row of what you can expect for rain or what you can expect for temperature. And so it's comparative from day to day. And nobody knows what the weather is going to be, but they can make predictions based on the past and based on statistical evaluations in the past. They can make predictions, and then descriptive statistics, people who engage themselves in descriptive statistics, work to make it as clear as they can for you, the outsider, to understand. So generally speaking, this is the form of statistics that most of you will have encountered, because most of you will have encountered statistics as a listener, not as a doer. So the doer side of statistics is called inferential. 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 statistics. This is the one that when you think about statistics, you really never think about this part, but you often think about this part. It's some mathy thing. It's the most mathy-like. Now, before you say something to me later, I know mathy isn't a word, but it's a word I like to use anyway. So inferential statistics is much more mathy. It has more rules about making sure that you run a good study and that you gather good data and that you evaluate data well for the best understanding that you can hand off then to the person who's going to describe it. Okay, so that's a lot of blah, blah, blah talk, I know. But it's helpful to know what we're talking about when we are talking about statistics. So now that we're talking about inferential though, and since it's much more mathy, let's look at those sort of rules. Like you want to ask, how do you set up a good study or a good evaluation? How do you gather good data? Well, the first thing you want to do is just specify a question. You want to be as clear and concise as you can. You want to identify a very specific population. So first thing you're going to do is come up with a question. Right? And you might say, well, how will the next election go? That would be a really good question. But who are you going to ask? Are you going to go into a kindergarten class and say, who do you think is going to be president next time? Of course not. But who would be a good group of people to ask? Because we're not going to be able to ask every single person on earth, who would you vote for? But we can ask a small part of a meaningful group and make inferences from that. So a good choice would be voters, people that you know vote. A better choice might be people that are registered to vote that you have records of having voted recently in the past. So people who voted in the last election are likely to vote in this election. And if you can ask that population, you don't need very many people before you can start to see a trend for the next election. So the first thing is come up with a question and decide how to select the sample, which is choosing your population. So once you've chosen the population of, for example, all voters, all registered voters that voted last time, what's a good sample? Is it okay to ask 3 of them? Would that be enough to make a guess? Probably not. Would it be good to ask 10,000 of them? Yes, it would. Would it be possible to ask 10,000? Absolutely not. So what's a good number to give information, to give enough information so you can make a good prediction? And how will you approach them? So you want to choose a sample that you can actually test and that will be meaningful. The next thing you want to do is gather the information from that sample. So you're going to gather information. Once you've gathered information from that sample, you have to then make inferences. You have to try to figure out what does that mean? Based on the answers from that sample, what do you predict will happen in the next election? And so you have to make decisions or make inferences, hence the name inferential stats. You want to make inferences from the data, and then the step that most people don't know happens, because we all talk about how stats is made up. Well, you know, statistics, you can say anything with statistics. Well, the good news is over time, not only have mathematicians and statisticians figured out how to gather and make inferences, but there's also a really good set of tools that help you determine the reliability. So you can actually check your work and be able to make predictions about how valuable it is. So for instance, you can go through this whole process where you come up with the question, who will win the next election? You sample, you choose a sample group, you gather information from the sample, you say, therefore, I think X is going to be the next president. And the next step is to say, and I have that feeling or that thought with a 92% confidence. So this is the important part here, the check your work. Learning the stats that lets you find out just how confident or how correct your data or your prediction is likely to be. And you can see by looking that this really is the branch of statistics that seems to be much more mathy. The math, speaking of, that you use in statistics tends to be pretty simple, meaning that the calculations you use tend to be, they can be tedious, granted, but they tend to be very simple and easy to process. So the math isn't the issue in statistics if somebody has a tough time in the class. What's difficult is knowing which equation or which formula to apply to which group and figuring out how to use the math in different situations is the tricky part. And so that just takes experience, and we'll have experience through working through various problems. All right, so let's look at an example to try to get at this inferential form of statistics. We're going to look at information gathered from 5 students that were selected from an entire undergraduate class at a large university. And the measurements and the table that we got, or the information we got, is, well, first let's identify. So we looked at 5 students, 1, 2, 3, 4, 5, just giving them numeric names instead of actual human names. And each student was asked about their GPA. First student had a 2.0. Second student a 2.3. Third student a 2.9, 2.7, and 2.6. So this would be called a univariate data set. So I've collected a set of data from a group of students, and I'm only looking at one variable. So the variable being the thing that isn't constant. So in the study, GPA would be a variable because you get a different value for each person or each individual that you look at. So this would be a variable, right? So GPA is a variable. And in this case, if this were the end of my study, I would say that this study is univariate. I had to look up the spelling. Univariate, right? So uni meaning one variable. The next thing asked in this study is the gender. And they found that 1, 2, and 5 were female, and 3 and 4 were male. So bear with me. This is an old source I'm getting this information from, and we're going to talk about gender fluidity in just a minute as a part of the example. But first, let's look at what we have for a study now. If my study stopped here, I would have chosen to look at the GPA variable and the gender variable. And because there are 2 variables being looked at, we could call this bivariate. Okay. Now let's talk about this. GPA is numeric, right? Easily identified as a numeric type of data or data value. When you get a numeric, or when you have a clearly numeric response or result to the question asked of an individual, we call that quantitative variables. So GPA would be a quantitative variable because it will result in a specific value at the time that you ask. Gender, on the other hand, if we look at gender as only male or female, we could easily make this quantitative if we applied a numeric value to each response. So we could say that females are a 1 and males are a 2, and we could create a numeric value for that. I don't think it would be valuable to do that, but it is something that we could do. We could create a quantitative variable for gender. But if we look at gender from the perspective of, let's say we have a female, let's say number 2 is actually a trans female. Now I've completely changed the two-sided or the two-option output for gender. And how does that change the way we would have to look at that variable? And because we know now that gender is much more fluid than even male, female, trans male, other categories exist, we know that gender is much more fluid. We have to ask, is this really going to be a good data point? We don't know. I mean, depending on the question that we're asking and the value or the way we quantify or the way we describe the output, this might not be something that is really a useful variable for us to look at. We don't know. I'm not giving a judgment. I just want to make the point that you have to evaluate whether or not you're choosing a good variable in order to evaluate the individuals in your study. Okay, moving on. I'm going to put in another one, which will make this whole thing tривariate. The next thing in this example was to look at the year that the students were in college. And 1 and 4 were freshmen. 2 and 3 were sophomores. And 5 is a junior. All right, so this kind of data is also non-numeric. Because it's non-numeric, we call this sort of data, well, let me write non-numeric first. Oh. Non-numeric data is called qualitative data. Or it represents a qualitative variable. So the last data in this study, or the last data gathered, was what is your major? So we have a psychology, math, English business. And again, because psychology, math, English business are not numeric, we have to say that this is a qualitative variable. And in this case, now that we have 4, this would be univariable if the study stopped at GPA. If the study stopped at GPA and gender, we would have bivariate data. If the study stopped at the year, we would have trivariate data. And once we get past tri, just like with polynomials, we just say multi. Okay, so we have multivariate data in this experiment, meaning each individual is asked a multitude, in this case, 4 multitudes, 4 types of data. Each individual is asked for 4 pieces of information that is unique to them, even if it could be repeated as this is English, right? So in the major, 3 and 4 are both English majors, but once you put more data to each individual, it starts to become more and more unique when you put it all together. So even though they're both English majors, they're clearly not the same. You have a 2.9 GPA, a male who's a sophomore English major, and in the case of number 4, a completely unique individual, comparatively unique individual, 2.7 GPA, trans male, freshman English. Definitely different than individual number 3. Okay, just a couple more quick definitions and then we'll be done. We call each individual who is looked at in this experiment an experimental unit. So we have we have a sample, right? So let me back up and say that again. We have a sample, I'm going to use a Venn diagram, we all love that, of an entire college population. Okay, so we have an entire college population. This is the population. Then from that, we take some sample group. So this would be called the sample of the entire population. And within the sample, we have number 1, number 2. Oh, that's not going to fit, is it? Let's do it this way. Number 1, 2, 3, 4, and 5. Within the sample, we have 5 individuals, and each of those individuals is called the experimental unit. So we have 5 experimental units in this study, and each of the data points we gather from them is called a measurement. So each of these is a measurement. 2.0 would be a measurement, female would be a measurement, freshman would be a measurement, and psychology would be a measurement on this experimental unit from this sample of the entire university population. That's not so hard to get hold of. And I have covered everything that we need to for the intro before we start actually looking at some more specific examples. I went a little longer than I like to go on a video. I also went a little talkier, but by the way, descriptive statistics is that whole talky paragraph thing. It's not always pretty, but it's always descriptive.